Hi everyone, good morning. Welcome to ST Skills. Today we are just having a mock interview, and the interviewer is Aseem, and the interviewee is Nisha Gambhir. And the format of this mock interview is how we are doing from the past few weeks is we'll have Aseem ask a question and Nisha drive the system design, and this may take about like 50 minutes to 1 hour, or like little like if we dive deep it may go a little further, but like at the end of this, like we will collect the feedback from the interviewer and also from the audience, and we will discuss like what can we do better or improve. Okay, with that I'll give the forum to Aseem and Nisha.
Yeah, Nisha.
Hi. Hi, Aseem.
Today, we are going to do a system design for top K heavy hitters.
Okay.
And I have put that in the chat.
Okay, I'll just write it. So top K heavy hitters. Okay.
So think in that way, I have a site like Facebook where people can upload videos, posts and things, and people can like things. So think in that way, I want to see top 100 posts which are liked at a point of time.
Okay, something like say most liked YouTube video, top K YouTube
or could
video,
be or think like a trend, what trend is going on. So the things which are being trend, I want to see top K100. It could be based on kind of views, likes. There could be different parameters based on the trend is set.
Okay, so I'll just make a note. Top K's views, let's say. Likes, comments, probably, right?
Could be.
Okay.
But we can go back to get back to. There could be some way to distinguish that. Okay, this is like view likes, but we can come to that later. But here the main problem is I want to see a trend or top K100 thing, heavy hit. It could be likes, comments, whatever.
Okay, got it. So what kind of functionality you want? You just want to get this top K views or likes or comment, these kind of things, right? You just want to query and the result should get back to the user, is it?
Yeah, think like I have a dashboard where I want to show top 100, top 1000 based on. It could be time based also.
Okay, got it. Okay.
I can go back in time or see the.
Okay. So how much time history are you looking for? So say for example, can we go back last year, or can we only store data for the current year, current month? Could you give an idea?
For now, let's say I want 6 months.
Okay, 6 months. Okay, I will.
But let's see based on your design, if I can see if I can go further back. 6 months. Start with 6 months window is good.
Okay. And how many requests would I assume that coming would be to this system?
When you say request for the top K or
viewer? No. So viewer. So let's say if I am talking about, let's say a video or say a comment, right? So how frequent that thing would be written?
So think in that way. This is a really popular site. I have a lot of users. You can, if you want to take a swag, that's fine. Otherwise, I can give you. But this is a popular site.
Okay, so can I assume, say, maybe 1 million requests per minute?
Yeah, if you want to start with that, that's fine.
Okay.
But this is actually really popular site. Like I have a lot of users which are hitting this site, viewing, commenting. So okay, you can get started with 1 million, or if you want
to simplify, like, do you want to assume whether it's YouTube or Facebook, like videos on YouTube or like?
So let's say it's a YouTube, and we are right now bothered about the views.
Okay. All right. Okay, so in terms of scalability or basically fault tolerance, can we afford to lose some of the data? Let's say if we don't have data for certain minutes in the 6 months, is that okay? Or should it be highly scalable, fault tolerant, that we cannot afford to lose any data at all?
So what do you think? What it should be? It should be highly available or not?
It should be, but then I mean, highly available doesn't mean it is fault tolerant, right? In the
So
sense that let's say if we are taking maybe if we are talking about database taking backups every hour, we
Mhm.
can lose data for up to an hour, right? So uh, does this system afford to lose data for few minutes, or should it be completely fault tolerant?
So, so you are talking about the dashboard, right? So where I will,
Yes.
yeah,
So
I
yeah,
don't,
the data that is coming to dashboard. Yes, yeah.
yeah,
Let's
okay.
say if I don't have data for 5 minutes in between, let's say, so can I average that data from maybe that day? Let's for example.
So I would like to be highly available, but I also uh, don't want to have kind of assumptions from the history. Whatever is the latest going on, I want that. But I could take some accuracy hit. That is fine for
Hmm.
me. But I
Okay,
want uh, kind of real-time system.
okay. So should be real time. Okay. Okay, so queries will only be top K of different things. Okay, all right.
Mhm.
All right. So if I have to think about the capacity planning for this, right? So
Mhm.
like how much storage should I have and how much CPU, memory, all those things. So if I assume that 1 million requests are coming per minute, right?
Mhm.
Then and how what would be the average size of the request, each request that is coming to the system? And when I say system, it means if I take an example of YouTube, when
Mhm.
somebody is playing a video, right, an
Mhm.
API request would be coming to get that video up to the user,
So,
right?
so that is a separate thing.
Mhm.
I think we can have a separation of concerns there. There could be a
Okay.
separate system which is handling how the rendering or other things will happen, and there could be a separate system who should be counting the views or something. That's what I'm looking for.
Okay, so the reason I'm asking is, for example, there are the way I would be storing the top K. For example, it'll be, let's say, video ID.
Mm-hmm.
Okay, and
Mm-hmm.
then maybe the frequency, let's say, right? So
Okay.
what would be the size of this video ID?
Oh, so you can assume based on you see like
Okay.
for now I'm okay with any size, but I think that is not that much important. Any modern day system could handle like up to
Hmm.
uh, I will say, let's say it is 32-bit, like
Okay.
or you want could be a long also. You can take like a 64-bit also, but
Hmm.
it is still fine. That is not that much of data. I'm bothered.
Okay. Okay. So for now, I'll assume it to be 32 bit, right?
Sure.
So if I take 32 bit, so it'll become like 2 to the power 32 bit, and then
Uh-huh.
the storage that would be required if I'm storing all the video ID will be around 16 GB, right? So okay, that is one.
Mm-hmm.
And I'm thinking about what else I would need to store. Okay, I might come back to this. Okay, at the moment I'm like thinking about how I would be designing it in the sense that would give me the top K likes or comments and all that thing. So the first thing that is coming to my mind is I could have like a hash table like I was drawing here, right? So let me do it here. So we have ID. Okay, this would be, let's say, video ID, and then I would have a frequency. Okay,
Sounds good.
and then let's say video ID 1, 2,
Mm-hmm.
3, so on, right?
Mm-hmm.
And then I would have a frequency. Let's say this was played 100 times, right? This was
Mm-hmm.
played maybe 1,000 times, and so on. And then the problem here is, along with this hash table, I can maintain a heap as well, right? Which will actually, as and when somebody is
Mm-hmm.
requesting for a video, right?
Mm-hmm.
At the same time, a request would come to this system as well, wherein I would have the video ID inserted into this hash table if it's not there. And then the frequency would increment by 1. So if it's not there, then let's say if the request now comes for say video ID 4, I will insert it and initialize the frequency to 1. Okay. Let's say the request comes for video number ID number 1, then it'll become 101.
Let's make it a little simplify for my understanding. So let's say you have 5 videos and I want top 2. What you will do?
Then if this is something like a sorted set with frequency, then I can just return first 2 items from this hash table itself, right?
Okay.
However, if the problem with the sorting
heap also.
Correct. So that's what I was coming at. So if I sort this hash set using frequency, it would take n log n time, right? So that's why I was trying because generally the sorted set is sorted with the keys, not the values. But here I want to return the videos sorted by the frequency, not the not the ID, right?
So you're telling like you will run some sorting algorithm, and the rationale of n log n is based on any
correct
sorting. Okay, fair enough. Okay, let's proceed further.
Yeah, other thing I could do is have this hash table like this only. So for example, this is 100,000, this might be 10 and so on, and have a heap together with this hash table, and that heap is a min heap. Okay. And that stores the element, only k element. So let's say if I want top 3, for example, right, then I will only have 3 element in this. So when user requests for the top k, I can just return whatever is there in this min heap. Okay, because it has only k elements, so I can return all. So first item will be the like k minus 3 top k, right? And then second will be sorry, k minus 2, and then k minus 1 and kth, right? So this will give the result in order of that.
So I think I understood your main heap concept. So good with that. But would you be updating? So how frequently would you be updating your main heap?
So I have to update it as soon as somebody views a video. Okay. I could decide whether or as soon as somebody, let's say, commented it or put a like or anything based on the system. So I would update it at that time. So anytime when I do any kind of update in my hash table, at that same time, I need to update my heap as well. I need to compare, basically. I need to compare the first element, that is the minimum element in the heap. I need to compare the frequency of that to the element that is getting inserted. So for example, let's say a request come for video number 1, right? Now it is 101, so it'll become 102. So I need to compare that 102 to the minimum element in the heap to see if the frequency of this is greater than that or not. Okay. If it is greater than that, then I will update my heap. Otherwise, I don't need to update it.
No, but if it is already there in the heap, what you will do?
If it's already there, then I'll just update the frequency.
Okay, then again, some heap operations will.
Exactly. So let's say if I just take a very simple example, I'll have, let's say, A. Okay, and
no, I think I got that notion. So I think, yeah.
Okay. Now the problem that I see with this approach is it is difficult to scale. I'm talking about one single system, right? But if we talk about YouTube and Twitter and all that, we cannot do this on one system, right? So if we have to involve multiple nodes, right, then I could have my hash table and min heap in multiple system, and then I can aggregate it. So aggregate it to an aggregator which will do the computation. The problem with that is the size will become too huge, right? If we are talking about, say, 1 billion videos and all that, that one system might not even be capable of getting all that data and then performing the computation.
Sorry, I didn't get that. Are you thinking of dividing this into multiple small subnodes?
Yeah, because let's say if there are 1 billion videos, one system cannot have this bigger hash table, and even min heap might become big as well, depending upon the case size, right? So I can't do this on one system, right? If I think about, I have let's say, okay, I'll draw nodes. So let's say I have 1, 2, 3 nodes, for example, and so on. So let's say I have one hash table here, okay, one here. So they will maintain their local hash table, wherein they will update the hash table as well as heap. Okay, all three will also have heap as well. And then they will give it to one other node, which is like an aggregator, which will be basically summing up. So for example, let's say this is one of the hash table one node has, and uh, it so one node, let's say this is node 1, it'll give it to this is node 2, will give it to this aggregator. They will need to, this aggregator need to compute or combine these hash tables into a single list and add those frequencies. So let's say node 1 has
Okay.
the
So what you are telling, like there would, so hash tables would live on separate nodes, and
correct.
if you come down a bit, so then you're
Yeah,
telling, then you're telling you will aggregate in one single hash table.
exactly,
You do something, but that's the same thing. I could have handled that in one single node earlier also.
exactly,
Why
exactly,
should I
exactly.
aggregate the hash table again?
Correct. So it will have trouble in that aggregating that. Uh, that's where I'm thinking about to use something called count min sketches.
No, hold
Okay.
on.
Yeah.
I think just before we jump on, so you told,
Sure.
like, why not you have your
Mhm.
K this heap and hash table in separate nodes?
Okay. If I keep the, so heap is minimal size, right? It is only of size k. So that won't be a problem. But hash table could grow in size on, basically. It could
But
become on.
but but you told you already split that hash table into multiple nodes.
Correct. I've split it, but then depending upon the volume of the data, right, it can still grow to a big size. And the problem is this aggregator. Okay, individual nodes will be able to handle it, but the problem is how would the aggregator be able to merge all these hash tables and have one big hash table? So it might not even have the memory
So you are
to
telling
do
like
that.
your hash, but I can add more nodes.
Yes, but then you have to do the same thing. So it's like you have to have more multiple aggregators here, right?
Why?
So.
If I put the heap also on the same nodes,
Mhm.
so the aggregator needs to only handle the heap, not the hash tables. Or I'm missing
Correct.
something.
Okay,
So
so you are saying that instead of sending the hash table, if I just send the individual heaps to this aggregator
yeah,
and they can,
yeah,
yeah,
magic. I
okay.
don't know, but some ideas coming to my mind.
Yeah, I mean, if I'm keeping the heap updated as well, which I'm doing in this problem, right? Uh, that could have the so the problem is like these three nodes, for example, here would have a k size heap and would have something like whatever that object is, right? Let's say a simple string or video id, and then the number of how many times it has been viewed, frequency.
Hmm.
The other hash table would also other heap in the node 2 will also have similar information. I could combine it. Okay, the aggregator could combine it,
Hmm.
right? And that would be easier to handle for the aggregator. Yes, you are right.
Okay,
Because heap, yeah,
mhm. But do you think with the scale and number of videos that could also become a problem?
yeah, that's what I'm thinking. Even so, if we think about the large value of k, right? If the k is
Mhm.
say in thousands or something like that, that would still become a problem.
Okay,
Because we could have in uh, so if k is 10,000, for example, so we would have 10,000 entries in heap
but
on each individual node.
can we do something like, because right now we are in
Uh-huh.
distributed computing world? Can we do something in a distributed fashion that which can help me? It might be
Okay.
slow, but it could help me. Do you think is it
Hmm.
possible with distributed
Yeah.
systems?
I'm thinking about if using Mapreduce here would provide any advantage. Uh, 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 the reason is because I already have the heap on all
Mhm.
nodes, right? So if I try to use, rather than directly the aggregator, if I try to use Mapreduce, right, it could split individual entries in my heap and then perform the map operation, wherein it would basically get the same. So it will have a map of each individual keyword, for example, right? And then it can have partitioning, wherein in the shuffle step it would combine all those. So for example, if I take A, right,
You
it
want to
would
write
combine.
something?
Yeah, I think, yeah, that would be better. So something like, if I have, let's say, I'll take a simple example. Let's say this is the entry. Okay, let's say A has been there or viewed 5 times. Okay, B is say 2 times. Okay, let's say C is there 6 times. And I'll just draw one more. D is there 15 times. Okay, now if I give this so let's say this heap. Okay, take an example when K is 2. Okay, so this is one heap, this is another heap. Okay, and let's just take example of 2. Okay, and then if I give this input to the Mapreduce, right, so first it will do a split of these. So these two will be splitted into, say, A will become 5, B will be 2, and then same thing will happen here. So C, and okay, I'll just put one more entry here. So A might also be here, right? So
Okay,
just put into,
fair enough.
okay, so instead of D, I'll put A here actually, because I could have same element in different heaps as well. So C and A, okay, 6 and then 15. Now in the next step, it would basically try to map these two, or partition the individual elements, in the sense that so if there are so many elements, so it will try to use something like probably we can use consistent hashing or something, and it would try to send these individual, for example, A might go to partition 1, B might go to partition 2, and so on, depending upon the hashing we are using. So it might be combined into something like, so A, it has to aggregate the data now, right? So this is like a shuffle step, and then so A, it needs to have this entry here, and it has entry here, right? So it would need to compute or combine both the entries. So it will become like 5 and 15.
Okay.
Okay, and then same will happen for B. So this data is now being combined here, kind of. Not exactly combined, but more like shuffled. So B is only 2. There is only single entry for B, and same for C.
Okay, I think I got your high level idea. You how you would use MapReduce, but I feel still it would be like you see like a lot of computations, and by the
Correct.
time if I ask for real time, it won't help me. So, no, and do you think something else we can do, or you mentioned about some other thing earlier?
Yeah, I was thinking about count min sketch
Okay.
algorithm, wherein for each item that is coming, we would have a kind of a matrix to keep a frequency. Okay,
What
so
exactly is that? And I
yeah,
would also
I'll
like you to give me trade-offs.
sure. So can I show first, and then we can
Sure,
discuss
sure, sure.
about
Go
it?
ahead. Yeah, yeah.
Yeah. So for example, I would have something like, let me draw this metric. So I would have something like some hash function. So let's say hash function 1, hash function 2, and hash function 3. Oops. Okay. And then I would have some number of columns. Now, how many columns I want, it depends upon the data set. Also, more number of columns and more number of hash functions I use, I would get a better accuracy. So this count min sketch is an approximate algorithm. It doesn't give you exact result. Okay, it might overcount sometimes, but it'll never undercount. It might overcount, but it is not an accurate algorithm. It is more of a approximate algorithm. So it'll give an approximate result. So let's say this is my column numbers.
Mm-hmm.
Do you know like how much error rate this Conmin sketch? I mean, like since you said approximation.
I'm not sure. Sorry.
Okay.
I think we can compute it. There is a formula. Okay, I don't remember.
Yeah,
We can compute it using this the number of columns and the hash functions we are using. There's a formula for that. I don't remember the.
Okay.
Formula.
Okay. Yeah, you can continue explaining. Then we can revisit. Yeah.
Sure. Now, if let's say A comes, okay, let's say request for video A comes. Now, what we will do is we will compute the value of each hash function for A. So this input will be given to hash function 1 for A. So A will be input for hash function 1 and some value will be given, and this value will be only these columns. Okay, it will be one of these numbers essentially.
Mm-hmm.
So let's say in this case we got 1. Okay, and hash 2A gave us say 3.
Mm-hmm.
Okay, and hash 2 was the first before this, and hash 3 gave us say 5.
Mm-hmm.
Okay, so I need to fill the values here. So let's say this matrix initially will be all zeros. Okay, I'll initialize it with zeros, and then when request comes, I need to fill the values. It's like more like I would increment the values by 1. Okay, so for hash function 1, I will increment at that column. So I'll put 1 here in the column 1, and I'll put in column 3 as 1 because this hash 2 for A is 3. And then I will put 1 in the fifth column. Okay, here. Now let's say the request for B comes. Okay, so I'll just mention the numbers here. I think it'll be easier. So now this is for B. Okay, so for B, this hash function gave, let's say 2, 4, and maybe 5.
Mm-hmm.
Okay, so this will set the values here.
Mm-hmm.
4 and then 5. So if the value already there, I'll increment it by 1. So this will become 2.
Okay. And now if somebody asks for the views, what you will do? Like if I want the view for A, what you will do?
When you say A, I mean, okay, somebody is trying to view A again. Is that what you say?
No. Now I want how many views are there for A.
Okay.
What you will do?
So using this this table, so I can I can count. So if I know the hash value for A will always give me this using the same set of hash functions, right?
1, 3, 5. Okay.
Exactly. So I will go to first column. So I got 1 here, and then third column, and then fifth column. So I get 1, 1, and 2. Okay. So 1, 1, and 2. So I will take the minimum element from this. And that is what I will consider my views for that particular item. And this might not, yeah, I'm sorry.
So coming back to your first thing, would this be undercount or overcount?
It will be overcount in this case because A count was actually 1, right? But since when B was viewed, there was a collision. So here we got the same fifth column for both A and B. So this 2 came, I mean, 1 was incremented to 2 because of B. Right. So, and that is why we are taking the minimum element from this list so that we can reduce the amount of errors. Okay. So in this case, this actually gave us correct answer because we are taking minimum. So it gave us 1. But in some cases, let's say, for example, another request came, right? Let's say C. Okay. I'll just, okay. Yeah. So C, and then we got say 2, 5, 6 maybe. Okay, I'll make this as, I don't know, I'm just trying to see if I can produce a collision, but okay, maybe, yeah, okay, it is 2 only. So this 2 will become 2, okay. And this is 4, so this will become 2, and this is, oh, I'm sorry, this can't be 6. I'll make it as 4. So this will be 1. Now, if I want to find out how many views are there for C, and let's take actually, okay, I'll make this as 5, then I'll be able to, I think, show you. Yeah. So this will also go here and this will give me 3, right? So if I now want to find out how many views were there for C, I'll get in my list 2, 2, and 3, right? And minimum of this will give me 2. But the actual viewed count was 1, not 2.
Okay.
So that's why, yeah.
So, okay, so there would be some error rates.
Correct.
It's okay. I think you can play around with your numbers or hash functions to reduce that. That is fine. So, what are the trade-offs? Other trade-offs? What do you think?
Before going to the trade-offs, like, is there anything else you need to do apart from? I mean, like, you have the results for all the like for all the elements. Like, do you want to use other data structure to get the?
So this table itself is, or this matrix is alone itself is not going to give me top K. This will help in if I want to find out views for an individual video, for example, right? So I need to maintain a heap as well along with this K-sized heap, wherein I would actually similar logic as before, wherein I will keep updating it, and I will only have K elements, and I will keep updating it based on if the frequency of minimum element in that heap is greater than what I'm viewing now. So whatever the new element came now, I would need to also check my heap to see if the frequency of the minimum element is greater than the count of the current view. So for example, if I take example of A, right, I can count how many views are there for that, right, the minimum count, right? So if I see the frequency of count of this is greater than the minimum element, then I need to update it. So I need both this and heap to give me the correct result.
Are you saying that you're going to replace your hash table with this?
Yes, that's true.
Okay.
Because this is more like a constant size, I would say. We can decide upon the number of hash functions we will be using and the number of columns we want to have. So this is more like a constant space, and we would be reducing the space to a greater extent if we use this.
Okay, so I'm fine with this, but can you run me through a end-to-end flow? And
Sure. Okay, so okay, I'll open a new page. I can't go down more. I think, okay, I have one more. Oops, sorry. Okay, I think yes. Okay, so let's say this is a user. What's happening here? I'm sorry. Okay. This was not selected. So let's say this is a user, and he will be sending the request to view a video. Okay, because this is more like it is for admin. User might not even look at something like that, right? So this is more like for internal analytics and those kind of things, right? So this would be a user, and let's say I'll just draw a boundary here. And so request to view a video would come into the system. So I would initially have something like, I'll draw a box, API gateway.
Okay.
I could actually put a WAF before it to have more security. So I will do that. I'll just make it here. Okay, so it'll come here and then it'll be going here. And then after the API gateway, so when the request to view a video comes, I would need to log that request somewhere, right? So that I can then process those logs in order to get these kind of analytics done, right? So let's say I would be using CloudWatch or something as my log aggregator. So I'll just take an example of CloudWatch. It could be something else like
are you having your are you having your counts or everything using API gateway and putting into some?
No. So till now, it's just a single request as of now.
Okay, go ahead. Sorry.
Okay. No problem. So logs will come to CloudWatch, and then this flow for the user request wherein he will see the video and all is totally different. As soon as I have the log in CloudWatch, now it is the pipeline for this particular design. Okay. So there would be something called I could use like a trigger. Okay. Wherein I could trigger a Lambda, for example.
Mm-hmm.
Okay. Okay. Or here I could have a kinesis. So I'm thinking about two options here. I'll talk about both. Uh, okay. So the advantage of using kinesis here is I could aggregate my log a little bit. For example,
Mm-hmm.
let's say user one viewed video A, then in next 1 to 2 seconds, he viewed one more video and one more. So it's like within say 2 to 3 seconds, he viewed 3-4 different videos, just clicked and started viewing and all that, right? Or even for different users, something like that. So I could aggregate my logs in kinesis and then send it for further processing. However, if I'm using Lambda, I can't aggregate in Lambda.
Mm-hmm.
Okay, that's a disadvantage of using it here.
Mm-hmm.
So depending upon the requirement, and I would prefer using Kinesis because being such a highly used system, if it is better if we could aggregate some logs a little bit so that the data we are processing would be reduced. So
Okay.
instead of processing one request at a time, I can process say maybe 10 requests at a time, something like that.
I think
Okay, so
that's
I will,
let's move ahead. Like
yeah, so
what
I'll
where
use
you
this. So yeah,
mean.
so let's,
Mm-hmm.
sure. So let's say this is, and then from Kinesis, this basically would send. So after aggregating the logs, it will send it to the SQS. Okay, so SQS will have this like a queuing system, wherein it would get the bunch of messages in the sense that each message would represent processing for multiple videos. So since Kinesis is aggregating the data, so I would get something like, let's say, A viewed one time. Okay, be
Mm-hmm.
viewed 2 times, something like that, for example. Okay,
Mm-hmm.
so it will get that information. Now from SQS, I could go to, I could have certain microservices here, which would be doing the actual processing and sending it to the further processing.
Mm-hmm.
So I will have, let's say, a processor. Okay,
Mm-hmm.
I can call it data processor. Sorry for my bad handwriting. Okay, and this data processor would basically process these messages. Okay,
Mm-hmm.
now when it is processing these messages, this data processor is the one which will have that heap available. Okay, so it can have this heap. Okay, now from here, right, uh, as I was talking about having that min count min sketch, right? So I could this did, so I could actually divide it into two different services or have one. Okay, I would prefer dividing it to different service because the amount of data that might be coming is more, right? So in case I would dividing it to different service, this will just get the message and parse the message and send the relevant information to another microservice. So there would be another queue here. Okay, so let's say SQS or something, and it will send it further down the line for processing. So this service, which I can call maybe this data processor, maybe count processor or something like that. Okay, this will have the min sketch. Okay, so count.
So I have a
I'll
question.
just,
So why do you have heap before
yeah,
means?
I was coming to that. In that case, if I'm using two different service, I need to have the heap on the same system wherein I have the sketch, because that needs to
Okay.
be updated whenever I'm, otherwise it has to again pass the messages all around, so too much chatter will be there. So I would prefer having it on the same host. So in that case, heap will come here as well. So this particular processor will contain both sketch as well as heap. Now this is if I talk about hosting for these, these would be part of a like a Kubernetes cluster or something like that, wherein so these microservices will be containers, and depending upon the data volume that is coming, it could increase the number of instances of the container as well. Okay, so in that way, I could have, let's say, multiple instances of container processor here, or even data processor if required, depending upon the volume of the data. Now each count processor has a sketch and a heap, right? So let's take, there are multiple count processors, right? So each has the sketch and the heap, right? So I would need something which would basically process that data, right? Process or get those, aggregate that data, get those individual local uh, sketches and heap, and then get the top K kind of a sketch. And if required, we can actually, in this case, we require to store it since we want like a 6 months history, right? So I could have a pipeline wherein I could use like Kinesis shards. Okay, I could use that. And the reason I will be using a Kinesis data stream, sorry, and
I
yeah.
think I'm pretty much not following, but I think overall I feel like I got your point, like how the high level thing will work.
So
So,
here it is similar only as to what we discussed before. The Mapreduce will come here, and the reason I'm using Kinesis here, because I could have sharding done here based on the that key, that video ID or something like that, so that in case the volume is high, this can process, and that Mapreduce will process individual data from each count processor, and will produce a top K sketch as well as heap, and we can then store it in a storage. So I would have like a S3 storage if I want to store in the form of object or something, or I can store it in DynamoDB S3 storage, or DynamoDB, depending upon, like, so I could make let's say if I'm using DynamoDB, I could make, I would prefer DynamoDB, because I could make, let's say, key as, say, top K comment, for example, right? And I know when I'm accessing that, I just need to go to that key and get the values from here. So it'll be faster than using S3 in this case.
I have a couple of questions here.
Sure.
First of all, I don't know like why you have chosen like so many components like CloudWatch, Kinesis, SQS, data processing, all before your count min sketch. I mean, like I'm sure like it may add some latency. That's what I think. But like you need to like explain like why so many layers.
Sure.
That's a technical side, but on the functional side, so you said like you're going to use count min sketch and min heap to get top K, and I think if I'm not wrong, like the requirement was to get both real time results, and also was it only the real time, or like you also wanted accurate results, Aseem?
So I want, for now, I want real time accuracy. I can take a hit.
Okay, so accuracy you can take hit. So your requirement was only to get the real-time results, right? So if you are talking about real time, then what is the requirement for MapReduce here? Can you tell me?
Sure. So even if we talk about real time, I would need to have that global top case somewhere, because each individual discount processor has their local sketch and local heap, right? So I have to aggregate that somewhere, right? So to aggregate it, I'm using MapReduce.
Okay, so I think it's the aggregation is basically you already have top K. Like, isn't the problem straight like a smudge sorted list or something like that? Or
No, so I
if
have
it is,
local top K, because based on the data volume, I could have multiple count processors here, right? So each will store it, whatever request is coming to that, right? So in that case, each would have its local sketch and local heap. So I need some aggregator which will basically combine all those sketches and heap. I could like use another service for aggregating it, because this will not be too much of data, right? So I don't really have to use Mapreduce here, right? Because this is not a big amount of data. So I could just have a service. Let's say this is okay, one set of services. So I have another service which will just do this processing, right? So it will take local sketch and heap from these services and just aggregate it, because I know sketch is also fixed size and heap is also fixed size, which is k, right? So it should not be too much of data for this particular service. So yeah, I think I can just go away in using MapReduce here. Shouldn't be required actually. Yeah.
Okay. And I mean, like, can you also explain the previous components? Like, apart from this count, min, sketch, heap, like you have many layers. I don't know what was the requirement of those.
Yeah. So initial, I could do some processing on API gateway, but then the problem is if I do processing on API gateway, then I would that would reduce response for the user as well. So the reason I did not do anything on API gateway is it should not have any impact on the user who is trying to view the video, right? So I just straight away from the API gateway. It is logged into the CloudWatch, and CloudWatch is the log aggregator. It is doing nothing else. It's like a kind of a logging system for your service. That's it.
It's a logging, but then like, so can't you directly accept counts from this API gateway directly to your data processing layer, or like?
I could do that. I could do that, but since we wanted 6 months of data as well, so I need to have it stored somewhere. That logs are stored somewhere.
Oh, you are using. Okay. Sorry.
So I think we are almost on the time. So anything you want to wrap up with closing thing, or you want to tell some bottlenecks, or if not, then we can wrap up.
Sure. Bottleneck with this mainly is the accuracy, right? This is not going to give the accurate result as we discussed before. And if we want an accurate result, then I would have to kind of use this MapReduce pipeline, wherein I would, from the logging system, right? I would actually use this. So whatever I kind of did not use here, this part, if I use this part, this is going to give me the accurate results.
Okay. And how about your API gateway and other things, or where you are storing data?
Yeah,
would that be a problem?
API gateway is a scalable service in AWS, so I don't need to worry about that. If load increases, it will automatically spawn other instances and be able to handle. It's a managed service, so I don't need to worry about that. CloudWatch can also store like billions of logs and all that. I can archive logs. So for example, in this case, I want only 6 months of data, right? Then I can archive the old logs to some other kind of a cold storage so that I can save on cost, right? So I could do that. And Kinesis also, if depending upon the data volume, it can have multiple shards. So I can configure it to have multiple shards, and each shard can handle some number of requests and all that. So because from CloudWatch, I tried using Kinesis because it is this log is more of a streaming data. It is keep coming from based on the number of requests, right? So so it can also scale. It's a managed service. I can configure it to have multiple shards and all that. And so this is also scalable, and SQS is also scalable. One more thing is, if I want to have that accurate result pipeline, then I have to make a change here in the sense that apart from this service, right? Either I can make a change from SQS, or here, I think it's easier to do it here, because instead of SQS, I can use SNS. So that same message.
Oh, okay. Hold on. What is SNS now?
SNS is a simple notification service. Internally, it uses, it's more of a PubSec model. So internally, it uses SQS only for each subscriber. So in this case, the idea is, because I want to use multiple pipelines, right? One for this, let's say, fast processing, and one for historical data, for example, right? In that case, I would have a different service for that. So let's say slow processor, for example, right? uh, in that case, this also needs to get the message. So if multiple services needs to receive message from the queue, I need to use SNS, because it's more like a pub sub model. So multiple subscribers can receive the data, and then everything else remains the same. It can use this, and in this case it needs to like use a Mapreduce. That's another change.
Okay, I think I'm good. So I think from my side I'm good. I can close this. Nagak, do you have anything to ask to wrap up?
Yeah, maybe like we can, since we are already close to 50 minutes, maybe we can just close, but like I have definitely questions around this using a lot of components, because
Okay.
the fact that you, yeah,
We can take that in the feedback,
yeah,
but anything as a system design interview, you want to wrap up anything?
she already discussed the bottlenecks, right? Like,
Yeah.
okay. Okay. Yeah, I
Okay.
think
We can then wrap this up.
okay. Thank you, Nisha, and thank you, Aseem.
Thank
So
you.
now, yeah, and we can talk about feedback from
Sure.
the audience, and as well as I can also give some feedback.
Sure.
So thank you for both for taking time to do this mock interview for us. So now open up for feedback. Do you want me to give feedback right away, or like open for people's feedback? So I can give mine quickly.
Sure.
Before we feedback, right? In general, it would be a good idea to have Nisha do like a assessment of how the interview went, and then we can then go to audience feedback, and then we can do like expert commentary from Naga and Aseem.
Okay. So Nisha, so can you do a self-assessment of you, like where you think you would have done good, or where you?
Yeah, I think I kind of mixed that fast and slow processing a little bit. I think when you asked, then I realized that. So I kind of I kind of mixed that a little bit in this section.
Do you mean like a real time versus the
exactly?
accurate one?
Yes, yes,
Okay,
yes.
okay.
I kind of mixed that a little bit, and uh, since these are all AWS components, I used, maybe some people might not be aware of that. So I think I should have explained what each component does first before including it, right? So I think that is another thing which I did not do. I think, yeah, I think that's what I thought I could have done better.
Okay.
Yeah.
So audience, like any of your observations, like I can go over mine last at the end. So
hi everyone, this is Deep here. So yeah, I think Nisha, you did really well. And I mean, my question is more about, I felt that overall during the whole phase, like, you always had ideas and you were just like, one after other, you were able to come up with things. Is it more like, having experience, or is it more like practice? Or, there were points like the Countman sketch, for example, not so much about the algorithm, but at that point when Aseem asked like anything else you can do, like you were ready with it. But if I'm not in that position, then it's like kind of, I wonder how to, navigate that stuff. And that kind of happened to me in a couple of places. So I would like to have everyone's, including, Nisha, yours, and in general, everyone's feedback on that process.
So I think I can give some pointers here. So const sketch algorithm is one way of solving this problem. If somebody knows, and might be the interviewer, if who is asking this question would be expecting that. In case the interviewer is not knowing that, then we can still go with other approaches like Nisha told. But I will say it's a bonus if somebody knows. That's what people say, that okay, read companies' blogs or see like how they are solving that problem. If somebody doesn't know, that's still fine. But if somebody knows, that is a bonus. And in this case, if Nisha was knowing, that it's fine. She could tell, okay, I have seen this in the past, so that could be one thing which we can use here.
Honestly, I also did not know about it till like 5 hours back. So if I wouldn't had known about it, then I would have gone with that heap approach and hash table approach, which again is not that scalable, might be okay for like small to medium kind of systems. But yeah, I think that's the best we could do if we don't know about
I
that.
had
And
to
maybe,
check with the Nisha, so we had some discussion
correct.
around that. So the idea here is like people should know if some algorithm they can bring to this problem. So in
Aseem, we are losing you.
Mm.
Hey, Aseem, we can't hear you.
can you hear me now?
Yes.
Yep.
Okay, so I was telling like if this algorithm is quite popular, so if you get next time also in a problem, then you can use it. And the idea here is to present in that way, so audience should also know like how to bring that in and use it. I know once there was an interview, I got asked like rate limiter. I was having zero clue about what algorithm I would be using, but I've tried other approaches and told, okay, I will do this and that. But it's always good, like if we know some algorithm which could be used. For example, API rate limiter, a leaky bucket algorithm could be used.
Correct.
So this is something like you come with more reading experience and such kind of sessions we are doing today.
Correct. Even Amazon uses leaky bucket only for.
But I was having 0% clue, so I used lot of other things to derive myself.
Yeah, thanks.
So I think that Nisha, when she approached the first solution and the second solution, and she know the second solution not gonna give an optimal or give the good solution, and she want to move to the third one, but Aseem was trying to assess why that the second solution does not work, and that suddenly consume a lot of her time, right? In that case, what she needs to do so that she can not go in that direction and go to the right direction so that she be able to complete.
I think she was able to complete all of it well in time, and she was also able to demonstrate different approaches, trade-offs.
Yeah, I feel at the end she rushed a lot, going through all of that component right there, and go and that would help her to give more time for her to.
Yeah, I think it's a good question, because I even I feel that like I could have explained the flow a little more better, and I could have completed that that historical data part, right? Which is I could not do it in detail. It's like high level only. Might be okay for system design, but again, like I kind of felt that I spent more time in that, but I felt it was also important if interviewer wants to know, right? It's like if he wants to know why you are using that and why not something else, it is good to clarify as well. So even if you could not complete some things in detail, it is still okay in my opinion. Maybe others can add.
Yeah, I think that would be for the interviewer to drive, right? So if he thinks he wants more details in the end component view, probably he could have. I think when Naga jumped in and asked about different components, you did cover some of those things. So
Yeah,
I think that was good.
So I have a
I think
question
in
on
a given
that.
time.
Yeah, so like Nisha covered different components, and when she was asked, and at some point she herself did kind of talked about why this and not the other one. But if let's say, and these are very like nice flow where we are thinking through data processing and everything. So can we, what if let's say we are not know about specific components? Yes, we can abstract them, but is there something like even to come up with this whole flow, thinking about these microservices. Um, I don't know if I'm just coming back to the preparation strategy, or is it like I felt that she modularized her component design pretty well, but how to even just think about it right in one shot? I mean, that was really.
So one thing
Nisha, I
is,
think we lost your screen share. I don't know, like just to have a
Oh, okay.
yeah.
Yeah, sure. 1 second.
so one thing I was thinking about is to answer this, what uh, I was thinking is that dividing the problem into first, like what are the functional requirements and what are the non-functional requirements. So like here we started with some of the non-functional requirements, that what is the scale, how many reads and write, and then we jumped into the functionality, that how we are actually going to implement the functionality. So I was thinking that probably like one component is this functional, one component is this non-functional, and then you start in terms of abstractions. So let's say I'm saying that somehow functionality I have implemented in a way that I'm giving to a database, that for this ID, this is the count, and I'm saying give me top 5. So now that database is handling the functionality, and now let's see how we handle the non-functional requirement. And then asking the interviewer, okay, now do you want to go deeper in the functional requirement, that how do a database, if we don't have, like if the database does not provide this functionality, how do we optimally implement the algorithm of getting the top K? And then going into this top K algorithm, that if the interviewer is interested in this functional requirement. Otherwise, let's say this part we are assuming we have abstracted out, that some way this thing is done, top K we are getting. Now how do we scale this, that in a database, a database can only provide about one machine, that in what machine we have top K. Now we have data in multiple machines, so how do we scale it and get the top K from multiple machines? So I was thinking in like in some way like that, approaching it, so the things are more clear and organized. Yeah.
Hello. Yeah, this is. Can you guys hear me?
Yes,
Yeah.
we
This is Ganesh. I just have, I think, a small observation, which I felt was like we started with this system is about the dashboard, and so basically this system has an input from some external system, let's say from the YouTube or something, where the views and the comments are tracked. So it might be a good idea to have some kind of an data flow diagram or a high level diagram in the beginning to understand what the exactly input and the output, which is the consumer made. It can be like dashboard can be from any client's mobile dashboard or anyone. So maybe the high level idea in the beginning might help to understand the data flow. So I think we can do that in the beginning. That might help in the process, and then we can deep dive into the low level components, the diagram that came in the end, including all the CloudWatch and other components. It might be a good idea.
Nice. Any other comments from anybody else? Thanks, Ganesh.
One thing I like to say is, before, since she's having more comfortable knowledge in AWS, before introducing the AWS, just she can say like, here I need a queue. In AWS, I have this one I'm going to use. Something like that. If the actual concept or logic, if she told, it would have been easy maybe, in case the other people are not having enough knowledge in AWS. That's all. But apart from that, she has very comfortable knowledge. It seems she was moving very fast and very comfortable.
So I just want to add a point here. Sorry, Nisha, it would be little critical here. I would be putting a critical hack here, but that is for the greater good. So what I felt is, like even I heard Vivek telling this a lot of time, like we have to take the interviewer to a right. So it's always good to, in between, check and ask the interview, are you following me? Do you have any question? Are you with me? Or if you have any, you want any clarity? Because when you started using all AWS components, the other person might not be knowing that. In my case, I knew that is fine, but could be, for example, you directly told, okay, I am using Kinesis, but instead of that, you would have mentioned I'm trying to use something like a stream-based technology where data could be streamed and be read by different consumers. It's a pub-sub model kind of thing, and different vendors who provide this is Kafka or Kinesis. And same for SQS is like, okay, I'm using a queue here. Different vendors could be SQS, EMS, or other technology, other companies which provide it. So in between, when you went to this, I know might be you are trying to be on time, but it looks like you are going alone, and I was left behind little. So just always have your interview with you, and it's always, I feel like I do like this way, like ask like, okay, are you following me, or do you have any question you want me to clarify something? So in this way.
Sure.
So to add on to that, that's what I felt. Even the interviewer was left behind, and the other thing is Nisha was driving all the conversation. That was good, actually. It was not bad, but the problem is, suppose interviewer had some different thing in mind, like he wanted to know more about the database side or something, or some other component he wanted to focus on rather than just algorithm. Then it would have been very difficult for the interviewer to know that thing. Like you were jumped into the problem solving, algorithm solving, and all those. So it was like from the interviewer side. If I am the interviewer, I will be like, okay, I don't know if I want to keep her or not. That's what I will feel that way at the end. I know everything was really good. You were talking about all the good concepts and everything, but still at the end, I will be not happy because I was not able to ask my questions there. There was less involvement from the interviewer side. That's what I felt.
Cool. Thank you for your feedback.
Yeah. For me, I think like I've learned a lot of new things, and I have a lot of things to go back and learn more. So I felt like a very good experience for me to attend this. Thank you both, Aseem and Nisha. It was a good session for me.
That's true. There are a lot of things, new things to learn after this today discussion.
Yeah.
It opened up many things.
Yeah.
So this was Naga's idea that let's bring something different rather than what we do. So yeah, thank you, Naga, for suggesting this topic. Naga,
yes.
If there are no more comments from folks, then Naga, I think you should go ahead with yours, and then let's have Aseem provide his perspective as an interviewer. And I have a few quick things to summarize, and then we can probably call it a day.
Okay. So I think my observation, like you both did a good job, and from interviewee perspective, like Nisha, I think you were too fast, like, and the audience were like having some, I mean, like they're trying to follow you, but like you were a little fast. That's what I also felt. And on when you actually started, like I think Aseem asked a kind of generic question, and he also gave an example like YouTube videos or Facebook. Like from what I felt is like it's good to pick any one example and stick with that, like in order to get better idea of the user scale, or like even for capacity estimations. Like I think you did a little later, so which is good. Like you are kind of estimating for videos, right? Like I assume. And on the requirements, I think like you try to gather requirements, but like I feel like they could be more clearly agreed with the interviewer before proceeding. I mean, like I saw like Aseem asked like for real time, and I don't know whether you asked like are you looking only for real time, or you also looking for the accurate results in the long run. So normally this real time makes sense only for the trend, okay, like in the hot trends or something, but systems still want an accurate results, in which case like you can still use Mapreduce as another path. So and and continuing the feedback, I agree with most of the audience that like you could have before stepped into these algorithms, you could have given like a high level flow diagram that in an abstract components, using abstract components, like this is my user, like he is viewing videos, and this is you, I'll be getting counts, and I'll be using some kind of processing, and then I'll have some kind of database, like at least like at a high level, and then like, and then you could have went into the algorithms, which is okay. That was one observation. And I think you were moving fast, and you explained the algorithm well, and with different approaches, which was very good. And you could have with Aseem a bit often, as some of the audience were saying. I think I forgot what I. And on the components, like I felt like you used too many components, which I mean, like I don't know, it every design involves like based on the knowledge that you have in that AWS, but I feel like it could be restructured with little less, I mean, like in a different way. Yeah, but anyway, like we can discuss that in detail if you're interested.
Yeah, I mean, couple of my side, like I think I got a little confused in this 6 months and real time, because of which I think if I have to only do real time, that design will be little simpler.
Yeah,
I kind of mixed both, I think.
Yeah, so because we are looking for real time, like you added too many components, which will add significant latency. So because you're adding SQS, Kinesis is fine, like it acts real time, because it's like Kafka streaming.
I mean, if you are to do
adding CloudWatch as one layer and SQS as another layer, is you're already adding some.
Yeah, I mean, if you have to do for
latency.
historical data and all, then we need those. But yeah, I think I kind of mixed it, because initially said like 6 months and then real time. I think I should have clarified better, probably.
Yes, yeah.
Because I think initially we wanted to cover both, but I think due to time we could not. So I should have probably clarified more to stick it to one, I think, yeah.
Yeah, I think those are my observations.
Nice, thanks, Naga. That was actually quite comprehensive. Aseem, do you want to do an interview perspective? Like, you know, what were you looking to get, and what part of it did you get? And I don't know if you want to do a pass-fail score.
Not now. If I have to do, I will do it private with Nisha. So here I would be. So first of all, thank you, Nisha, for taking this being an interview. And this is not so easy. So really appreciate that. And what I felt like you started well. Could be for others, you might be moving fast. For me, it was fine. I liked your pace. If you're going at this pace, I was okay with that, because you are going to different things, and I was able to follow you. If I'm not able to follow, I've stopped you. Okay, what you are doing here, or so that is fine for me. It is again for me as a, if I'm a be an interviewer. So the things which I think could be done different is, again, I think people mentioned about this component diagram. This could be simplified at times. That is one thing. And before jumping to that count min sketch, you would have told like why I'm doing that, because and then you can go back to the requirements. Hey, you told me that accuracy can take a hit. because we want real time. So there's an algorithm which I know which can be done in real time. Accuracy can take a hit, fixing to a requirement. So do you think like we should proceed with that? Then I guess, okay, looks like I'm okay with that, and then we can go with that. That is one thing. And at the end, I think when I asked about bottlenecks, I'm fine with that, but I wanted some better thing. Like what you have told about the bottleneck initially, like it is not doing accuracy, but that is something which I have discussed earlier. So I was looking like, okay, what could be a single point of failure? It could be a DB, it could be an API gateway. So that could, if you could have told on the component side, that's something I was looking for. I think that is overall feedback from my side. But yeah, I felt like you are good. You have clarity of your thoughts. So that is one really good thing which I felt. You have, so I can easily see that you have a lot of good experience with different technologies. It could be easily seen from this interview. It's not clear to me or not, that is a different thing, but I can see you are an experienced person and you know things. Yeah, Vivek, if you want to summarize.
Awesome. Hey, thanks, Aseem. I think you've covered most items, and I wanted to push back on the pace, and thanks for doing that as well. So I think, Nisha, I listened to the whole interview, and I was also keeping track of the time, as in when you were doing what part of the story and things like that. So at a very top level, like summary-wise, I think your command over the subject, the components, the technologies, those things actually surfaced very well. So one of the things that I look for as an interviewer would be to put a checkbox against saying, does this person understand the common technologies that would be used to solve any problem, whether it is like a queue or a stack or whatever data structure or whatnot. I think you came up more as like someone who is somewhere between an intermediate and an expert. And the reason why you didn't come out as an expert is just because of time. I think you could have very well been an expert, and I wouldn't know. Like, there's no negative signal. I just got positive signal that you're not a beginner. You're definitely an intermediate, if not an expert. So that aspect, I think, is like you knocked it out of the park. So there is no, you're very comfortable with it. You're very fluent with it. You are accurate with it in terms of like, using the right technologies, terminologies, and everything else. So that part of it was brilliant. And I think you intimidated a lot of folks in the audience because they're like, holy crap, like, I don't know all of these technologies and whatnot. And really, do I need to know all of these things to be successful in an interview? Maybe not. That's like for everybody else. If as long as you're better than a beginner and somewhere in the intermediate range, you should be fine. And Nisha has been awesome. So she's been on the expert territory. So that's kind of like great, but that's not expected from most senior engineers. So that part of it was fantastic. I had few pieces that I wanted to go over overall in terms of structure of the interview, right? So this is something that you may want to keep in mind. I have posted this in the chat as well, so for folks can follow along. Typically, I would expect about 5 to 10 minutes of requirements clarification and problem exploration, just trying to understand who the actors are, what are the responsibilities of each party, and things like that. You started out well, but then I think went into too much of the requirement clarification, went into a lot of details around how exactly those things need to happen. Like one of the questions around saying, like, can we afford to lose data was a question. Like, why ask? Why not assume? They've already told you what the system looks like. So you should be able to go through all of that. Around the 10-15 minute mark, you already started talking about the actual design of it without the high level design. So there was a little bit of a confusion in terms of how you wanted to go ahead with it. So my recommendation would be to talk about the requirements. And when we talk about requirements, you talk about both the functional and the non-functional requirements. I don't think we talked about the non-functional requirements in isolation. Like, we talked about it specifically later as we went through the conversation. So not doing a good job of the non-functional side of the requirements was definitely a problem, which came back in multiple times. The second phase would be a high-level component design, and this is where around somewhere in the like, the 30-minute mark, right? The 35-minute mark is when you drew the end-to-end diagram, the one that we are seeing on the whiteboard right now. This is the diagram that I would have started with to some extent, like, draw the block diagram, saying here is the user, here is what it is and whatnot. You have to start with the high level component design and let the interviewer guide you to what they want to discuss more on, as opposed to like, you controlling the conversation. So in this case, I think it was flipped. So did a lot of these things, like count min sketch discussion, I think was almost like 10 minutes, if you can go back and watch it. And I think that I don't think added any value. If I had like 10 checkboxes in my interview list, count min sketch will not actually give you any of the checkboxes. So you spend 10 minutes of a 50-minute interview, 45-minute interview, which is precious time, on a component which is not relevant, and it is interesting to the interviewer. So Aseem spent time on it, but it would not help him check any of the boxes, right? But in terms of have you taken care of functional requirements? Have you taken care of non-functional requirements? Did you consider bottlenecks? Those are all the checkboxes that he'll have. He will not have a checkbox which is specifically saying, did the candidate know obscure data structure, which was absolutely relevant to the problem, is not a box. These are extra points, but you got lucky because you were able to cover the whole interview, and so this was like a brownie point for you. But this could be dangerous. Like, if you did this and you did not solve the question, or if you did not do well in other areas because of this, it's a poor use of time, right? So that is one thing to keep in mind. The third part of it is where you talk about the low-level design and specifics, algorithms, and whatnot. The audience had this feedback while you were interviewing, while you're doing the interview, around you were jumping across multiple solutions, and your solutions were not necessarily building on top of each other. Like, you had one solution which was heap and hash map based, and then you had a second solution which was Mapreduce based, and then you had a third solution which was again using count min sketch, which is like a variation of the first solution. But too many solutions, and maybe like there was not enough time to go through the specifics of each of them and whatnot. So there may be like understanding the high level component design, then you can use that to drive the low level would have been easier. So that's something for you to think about. From a timing standpoint, I would expect about between 5 to 10 minutes of requirement clarification. I think you did a little more, but you didn't cover all of it. High level component design came later, and that I think was appropriate in terms of time, but not in terms of positioning. Low level system design, I think, took longer because we spent discussing count min sketch algorithms. And the last one, which was actually, I don't think was covered, was system verification, like going through and making sure that the problem has been handled. Aseem mentioned two things, right? One was essentially, if I were to go and look at something, I need you to tell me what are the top 10 videos. And that's it, that is a requirement. And how does that top 10 get added is by whenever somebody is watching a video, you automatically go and increment that video's count. That flow you have to verify with your system, saying go through this like this is like testing your code, right? You have to test your system to make sure that all the wires have been connected. Like if you had missed a wire, if you had misconnected something and things like that, then that will show up in the verification. So that didn't happen. So that's something I would not too much time, but what 5 minutes on that would generally work. So overall flow, I think if you restructure your interview approach with these things, you have the fundamental skills. You are like, plus on the skill side of the story. So if you do this, your interview will be amazing. To be perfectly honest and critical, this interview could have been a hit or a miss depending on the interviewer. Some interviewers might take this and say, yep, awesome. And some interviewers may come back and say, you know what, I really don't have all my checkboxes checked. So I don't know if I can say yes or not. I kind of feel that the candidate knows all of these things, but we didn't have a chance to discuss this. Like we didn't go through all of those. We didn't do that. Like if I had more time, I could have done this. And no data is actually negative data. So you may end up being on the negative side of the story despite being amazing, right? And that is because of the process aspect of it. So just focus on the process, and I think you will do fantastically well in any interview. So that was the overall structure. I had 2 or 3 other quick comments. So I just wanted to lay it out there, and then I'll let people ask more questions. Airtime. Typically, I would expect interviewer and candidate to have like a 40-60 breakdown, with the interviewer spending about 40% of the time discussing, and the candidate or the interviewee spending about 60%. So it's about a little more for the candidate because obviously you're answering. I think in this case, it was more like 2080. I think Aseem did a little more talking in the beginning, and I was a little afraid that he was doing a lot of talking. But then once you got into on a roll, you were essentially dominating the conversation, taking the direction and whatnot. Now, this is like something up to the interviewer. Like a good interviewer would probably find a way to interject and claw back and keep that rhythm. But at the same time, if you're saying the right things, an interviewer might let you go astray. But if you go astray and the interviewer is not able to get the right amount of data, it will again negatively harm you. So I think Naga mentioned this and Aseem mentioned this as well. It is your job to keep checking with the interviewer, saying, does this make sense? Is it okay? Like, do you get it? Do you need more information, and so on, and then keep going, right? So that is something that I think you missed. And I think that's something that you can definitely do way, way better. More than all of this, I think this is like an excellent interview. I just wanted to highlight some of the areas where I think there were like small gaps and whatnot. This is like a typical interview that I would see, which is where great candidate, but like borderline interview, could be positive, could be negative based on what it is. And maybe I think the way this would be, like, you can definitely make this better, would be to solve the simple cases first. And then once you solve that, then you can start adding complexities, because you're going into one of the things I saw was like about 22 minutes into the interview, you talked about consistent hashing. I mean, we are not even talking about availability and things like that yet. Like, let's solve the simple case first, like the min heap plus hash map equals output, and then make sure that that works, everything is covered. Then let's talk about how to make it more efficient and whatnot. Like, you're jumping ahead in some of those areas. So that is all I had. I might have come across as a little bit more critical here, but I think overall this would have been, in my mind, I would have thought of it as a positive interview, but I can easily see some of the interviewers might take this as like a negative interview or negative result, because yeah, the candidate knew a lot of things, but got confused and overcomplicated things unnecessarily. Could be a feedback that might come out. So it's a crapshoot. You don't want to be at the mercy of the interviewer. So happy to answer any questions that people have on this summary. Otherwise, Naga, take it away.
Thanks, Vivek, for giving
yeah, thank you.
wonderful observation.
I have one question, if I can ask.
Yeah, sure.
Yeah, so Vivek, you talked about like starting from high level diagram only, but in this case, I mean, the solution relies more on what algorithm is used, right? So should we still start from the high level diagram and then let interviewer ask the algorithm if they want to know in detail, or I'm a little confused on that part?
Actually, no, that is not true, right? In this case also, like, what if it was top N, but the total number of entities that we talked about are not that many?
Mm-hmm.
Like, let's assume that this is essentially top 10 actors, right?
Mm-hmm.
We don't have millions of actors.
Correct.
We may have millions of requests, but there are only like 10,000 actors or something that we care about, and that can easily fit in memory, right? So depending on what the use case is, I think the crux of your problem is two parts of the story. One is, when I ask a question saying who are the top N now or top K now, I need a list back. That's like use case one. Use case two is, I'd like to contribute saying, hey, item 1 got a +1, item 2 got a +1, item 3 got a +1. These are the two APIs that we need. That's it.
Mm-hmm.
And then you need some kind of a data store in the back that keeps track of it, which is essentially a hash map, which is what you got as well, right? And then you're saying that now in a hash map, I can always find the top K in a very expensive way, but let's be a little smarter than that, right? And the way we can be smarter is by doing K log K, which is using a heap data structure, and that's how we'll deal with it. Now, this is the block. Now let's talk scale. Let's talk other things. And then once you add scale, if you say, oh my goodness, we are talking about products and Amazon scale, so which means we are talking about some 100 million products or 200 million products, and a hash map is untenable. So what do you do? And then the question will be, then, like, you know what, let's not use a hash map, let's use a count min sketch, because accuracy is not important. We can do it this way. Or Next one is what if it's not top n, but it's like top whatever, top 100,000 or something like that. Instead of like, it's a very, not a small k. In that case, you would say, let's try to do a distributed heap or something like that. Like use a heap structure, but it is stored across multiple computers or something like that. And then let's figure out. So I think you need to let the algorithm evolve. The biggest problem with these things is that we have seen these questions so many times. So we do approach these questions, like, we approach them with assumptions already pre-baked, and you are producing like the final output right off the bat, which is not the right thing. Like, I wouldn't even, like, heap is not the thing that I would go to till, like, first step is the hash map so that I can do the counting. And then the next step is the heap so that I can get the top key out of it. So it should be an evolutionary process in the interviewing mechanism. And I think you should be able to do that, is my feedback. I mean, I've seen it done multiple times. And there are similar problems, right? The Google type ahead is another question that actually uses a similar approach, right? So they're all, and there it's a try-based structure. Now, you don't need to start talking about tries right off the bat, right? That is, just because you know the answers doesn't mean that you have to just jump right there into that one, right? That'll negatively impact you, because come to think of it this way, right? If I come to you with a problem, and let's say you're working in my team, and I am like a senior engineer, and I'm looking at you and saying like, hey, Nisha, go design this for me. And you kind of like make random assumptions about how it is, and you start designing a finer point system without considering all the obscure cases that are unique to that particular problem statement that I've given you. Then that's a problem. I don't want you jumping into conclusions, right? I want you to start building up and making those intuitive decisions. It's a decision tree at the end of the day, and you have to go through that process from the starting. Start from the abstract, first base level requirements, make sure that you're layering on your solution up front. And that's exactly what you do in your day job as well. This is not just an interview process.
Yeah.
That makes sense?
Yeah. Thank you.
I think this this solution it only cover the top K, right? But like when Vivek mentioned that, let's say he want the top 10 actor, then this solution not going to work, right? Because if that's the case, we have to categorize it based on the actor.
So it would work if you call individually, like if you know those 10 actors, and you can pass some ID or whatever, that string of those actors, and then it would work. But yeah, I mean, it will not work without providing that input. Yes.
So the same problem can be done. Instead of tracking video ID, if you're tracking actor ID, then the whole problem just becomes that, right? So if you think of it as IMDb, where they have like popular actors, like people are looking for these things, then the ID in that case is the actor ID, and the exact same solution that Nisha has here will work for that.
But so given that ID, you have to extract that ID belong to what category, and then you will get the top K of that in that category, right?
Well, I mean, yeah, whatever the input is. If the user is looking for advertisers, actors, customers, whatever, right? Best selling products, as long as you're tracking the same product, same item, the output will be, the top K will work, because the algorithm is pretty straightforward. And I think Nisha did a good job of explaining different aspects of it.
So one question I have is, if we are actually implementing this and our heap, we are using heap data structure, it's in memory, but we have to take a backup of it, right? Because if the system crashes, we have lost the top K elements. So yeah, I mean, each of those components can go very deep.
Yeah, and again, in general, the heap is a cache, right? So you can always go back and, I mean, if you destroy the heap, you still have your hash map. You can go back and reconstruct the heap without much of a pain. But again, that said, you may not want to rely on that. Like, it may be too expensive to go through 180 million products to fetch the top 10 products. So you may want to keep backup in different ways, and you may want to persist the heap in some way, keep it redundant, and maybe use like some kind of distributed heap concept there. Lots of interesting ways to take this forward from an interviewer standpoint. but anyway, I mean, that's but good point, Abhishek. Like we will have like persistence and data like in redundancy and failover are important aspects that could get discussed. We talked about bottleneck in this interview, but those are other concepts that can be explored.
Yeah, we were discussing some of these during our book club today. So, nice connection.
Yeah.
Okay. Any other feedback from the audience?
Yeah, I have a question actually. I was just, or maybe it is answered, but I missed. So, what should be the like, because this hash table or hash map, which has the video ID and the count map. Sorry, my daughter is trying to speak too. So basically, how big this should be? Because as I think Vivek mentioned, there can be like 2 million product, and so there is no point in keeping, let's say, there is one product which has only one view, in the hash map, right? Because it is unnecessarily increasing the space.
Yeah,
So,
there was a section where you saw Nisha was talking about using multiple hosts, like each host having a hash table, and then like there will be which aggregates, which gets the counting. I mean, like
that's like a distributed cache, right? Where
yes.
But there should be a limitation to that too, right? Like
yeah, correct. Yeah, obviously, like depending on the number, like you need to decide the number of hosts, and
yeah, I think
there should be a routing.
The conversation that I think what Ganesh is getting at is that if, imagine you're looking at top K products, right, at Amazon, sold products at Amazon. Would you keep track of all the orders? Because there will be a lot of obscure products which only are bought one. There is a long tail, right? Only once, only twice, and things like that. And no product which has been bought less than say 1,000 times an hour has the chance to be in the top 10K or something like that, right? So if that is the case, why would I want to store that whatever thing? Now, you are picking winners and losers in that case, Ganesh. Like let's assume you keep a threshold of saying, you know what, I'm going to keep everything that's more than 100. Okay, that's what you did. So there could be a product which was bought 99 times, and then somebody suddenly, like in the next 5 minutes, somebody bought it like 500 times or 1,000 times. Now that could have made in the top 10, but because you discarded 99 hits, it didn't make it into the top 10, and that's not at the end of the day, it's not the end of the world, right? The top 10 is more of a feedback, and nobody's going to sue you for having a wrong top 10. This is not like voting for the president or the prime minister or whatever, right? So it's not. It's the accuracy is and Naga and Aseem mentioned that a few times. Like accuracy, I am willing to sacrifice both in terms of time and also in terms of numbers. It's okay if you are approximately the top 10 is fine, as long as you're not telling me that the 100th product is the top product or something. I'm fine with that. So with that, there are some interesting trade-offs that you can make, but I don't think an interview will go into that, because those trade-offs are those are practical trade-offs, and those happen on a very case-by-case basis. And in an interview, since it's a very hypothetical scenario, it's very hard to get to those kinds of trade-offs. So I think the best that you can do is a count-min sketch, which is a probabilistic data structure, which kind of gives you mostly the right answer with some errors here and there in case of collision. And that's probably the best. But I don't think, as an interviewer, I wouldn't go into that aspect of the story. I think the focus is more around you identifying that you need to store all the values, and you need to store the top K as two different elements. And then how are you keeping track of each of them? And what is your mechanism to update all of them? And are you handling scale at any point of time? Like we talked about 1 million transactions per minute, but I don't know whether it went to anywhere. Like we didn't talk about how many computers do you need, how many instances or anything else. Like 1 million transactions is about 17,000 transactions per second. And somebody said it can be done on one computer. I disagree. The number that I generally use for one computer for processing is somewhere between 500 to 5,000, depending on the scale and the size of the system. So I think 17,000 is still pretty high, even if you consider like base IO and everything else. Maybe there are instances which can do more than that, but I generally go as a rule of thumb between 500 to 5,000 as my transactions per second, like a computer can handle. Ganesh, does that answer your question?
Yes. Yeah, that answers my question. I mean, I had some other, I mean, I was just trying to think about that solution to where you keep the min value, like min count. Let's say I keep 1 million records in the hash table. But I think, as you mentioned, it's not, interview may not go in that direction. So yeah, and there are some trade-offs to make if we want to make that decision.
Yeah, totally makes sense.
Yeah,
awesome.
thanks. Yeah.
Thanks for the question. All right, that's all. Naga, back to you.
Okay. Any other questions? Or maybe I can stop recording and maybe we can discuss about the next week, upcoming weeks, how we can plan this.
Yeah, I miss it. I don't know what was the limitation of using the hash map and the mean heap. Why it doesn't work?
I mean, for the real time, you need to keep recomputing,
Nisha,
right?
Nisha, do you wanna answer that question, Nisha?
Yeah.
So basically, it would work for like a small and medium type of load. But if we are talking about billions of products and all, in your hash table, you could have all those coming in, right? Depending upon what product is accessed, right? So the problem is with the scale, wherein even if you have multiple nodes and we cannot have just one node for handling, say, 10 products, right? Otherwise, we'll be paying so much for the nodes only. So it is difficult to process and scale this system. That is why we chose a different approach to have the close to constant size. Okay. Another is for real-time system, as Naga was also mentioning. We don't really need to have that hash table at all, right? Because we don't need to store data with relation to product in the sense that we don't need this much of space, right? If we are storing all the products, we don't need that at all. If we are just want to return real-time data, right? But even if you want to have the historical data, right, and if we are using hash table, still scaling will be a problem.
Okay, got it.
You want to add something, Naga?
No, I think you are good. Any other questions from anyone? Okay, I'll stop the recording and maybe we can continue discussing the plans for next week.
Stop sharing.